Hello students, in this video I will explain the conversion of NDFSM to DFSM using subset construction method. The steps in the conversion of a NDFSM to a DFSM is as follows. First we identify the start state of the DFSM, followed by identifying the alphabets of the DFSM. Then we identify the states QD of the DFSM, identify the final states FD of the DFSM, and then we can identify the transitions delta D of the DFSM. We shall take an example question which goes like this. Let L be a language that ends with substring AB over a set of alphabets sigma is equal to A comma B. And we have to convert this into DFSM by the subset construction method. Now, constructing a language L, which L ends with AB, then the structure would look like this. It has to end. Every string in this language has to end with the substring AB. So first we see a A and then we see a B. And prior to this substring AB, it can have any number of A's and B's. Therefore, NFSM will look like this. We have our start state Q0. Q0 sees a A, this part, and it goes to a state Q1. Now Q1 on seeing a B goes to Q2 state. We have come to the end of this string. Therefore, Q2 is our final state. And prior to this, we can have any number of A's and B's. Therefore, in the state Q0, we can have any number of A's and B's. The transition function for the NFSM which we have constructed for a language that ends with the substring AB is given as, we can write delta N. We know that we have two inputs A and B. So the start state Q0 on seeing a A, it can go to two states. We can see it goes to Q1 state and it remains in Q0 state. So Q0 and Q1 are the two states, and Q0 on seeing a B remains in Q0 itself. Next is Q1 state. Q1 state, we do not have any transition which is defined for A, therefore it is a dead configuration, and for B it goes to Q2 state. And Q2 state, we do not have any transitions which are defined, therefore we can write it as dead configuration, and we know that Q2 is our final state. Now this NDFSM has to be converted into a DFSM, which is a 5-tuple configuration. We first will identify the start state of our DFSM, and we know that if Q0 is the start state of our NFSM, then Q0 will also be the start state of DFSM. The next step in the conversion is to identify the alphabets of DFSM. We know that the alphabet set of NFSM is equal to the alphabet set of DFSM. Therefore, here sigma is equal to A comma B in the case of NFSM. So for our DFSM also the input alphabet is A comma B. In the next step, we will identify the states QD of the DFSM. Now we know that the states Qn of the NFSM are equal to Q0, Q1 and Q2. We have got three states. Therefore, N is equal to 3. And QD, that is the states of the DFSM, is 2 to the power N, that is 2 to the power 3 equal to 8 states. So constructing the subsets of Q0, Q1 and Q2, we get QD is equal to empty set, then we've got single element set, Then we've got two element set, Q0 and Q1, and Q0 and Q2, Q1 and Q2. And we've got a three element set, Q0, Q1 and Q2. So these are our 8 states of the DFSM. The next step which we consider in the conversion is to identify the final states FD of the DFSM. Now we know the states of the NDFSM and DFSM, right? It is QN and QT, the states which are listed under QN and QT. Now, the final states of DFSM are the subsets of the final state of NDFSM. Therefore, if Q2 is the final state of NDFSM, then all the states which contain this state Q2 will be the final states of DFSM. So we've got a Q2 state here defined, we've got a Q2 state here, we've got a Q2 state here, and we've got a Q2 state here. Therefore, FD is equal to Q2. We've got 4 final states, Q0, Q2, Q1 and Q2, and Q0, Q1 and Q2. In the last step of conversion, we will find out the transitions delta D of the DFSM. Now, in order to find the delta D of DFSM, we need the QD states of DFSM. So we know that we have got an empty set. We've got Q0, Q1, Q2, Q0, Q1, Q0, Q2, Q1, Q2, and Q0, Q1, Q2. These were our 8 states. These transitions functions will be defined for each of the 8 states of your DFSM. So for state phi, that is empty state, when it receives input symbol A, delta phi on receiving A. We do not have any configurations which are listed out, therefore it is empty state itself. And input symbol B. Again, we do not have any configurations which are defined, therefore it will be a 5 or an empty dead configuration or empty set. The next state for which we can write the transition is this Q0 state. So we have delta D Q0 on seeing an A and delta D Q0 on seeing a B. Now the transitions for Q0, delta D transitions for Q0 will be the same as delta N transitions for Q0, because the start state for DFSM and NFSM is the same. Therefore, Q0 on seeing a A goes to Q0 and Q1, and on seeing a B goes to Q0. But we know that under DFSM, we have to go to only one state at a time. So this is fine. A state transition on B is fine because we go only to one state. Whereas on receiving Q0 on receiving A goes to 2 states. This is one state and this is the second state, which is not possible under DFSM because on an input it should go to a single state. Therefore, what we do is we consider Q0 and Q1 together as our new state in DFSM. Anyways, this state Q0 and Q1 is present. Therefore, we can consider Q0 and Q1 as the new state which is defined.
I will make use of a tabular column in order to write all the transitions delta D of the DFSM. We have delta D and two inputs A, B. I'll write out all the states of the DFSM. We had state 5 or empty state, then we have single element states, then we have two element states, Q0 and Q2, then we have Q1 and Q2, then we have Q0, Q1 and Q2. Here, since Q2 is the final state of NFSM, wherever Q2 is present as an element in the states of DFSM, we consider all those states as the final states of DFSM. Taking the first state, that is 5, we had seen that there is no transition on any of the inputs, therefore it is 5 for both the inputs. For state Q0, we take the same set of transitions as that of delta N. Therefore, it will be Q0 and Q1 and Q0. We had seen that these two states were the two state transitions which take place for NFSM, but since we cannot have separate states for a particular input, we can go to only one input at a time. In the case of DFSM, we consider or merge both the states and consider it as a single state. Then we have state Q1, transition for state Q1. So here we can see that there is no transition, so we consider it's an empty transition, therefore it is 5, whereas Q1 on getting a B goes to state Q2. Next is the state transition for Q2. Now in the NFSM we do not have any transitions which is defined on state Q2, so both these state transitions are dead transitions. Next, taking the state Q0, Q1. It's a combination of two states, Q0 and Q1. Therefore, transition delta D on the state Q0, Q1, it is to be considered as a single state. On an input A is written as delta N transition of Q0 and A union delta N transition of Q1 and A. So separately we'll see the delta N transitions of state Q0 and then Q1, and the union of these transition states is considered as the transition state of this state Q0, Q1. Therefore, we have for Q0, Q1, we have Q0, Q1 union 5. That is equal to Q0, Q1. So on A, Q0, Q1 state goes to Q1 itself. Now considering for input B, we can see that for input B, it goes to these two states. It will be union of these two states. So if we are considering Q0, Q1 on B, then we'll have delta N transition of Q0 and A, Q0 and B, and delta N transition Q1 and B. Therefore, we have Q0 union Q2. That will be Q0, Q2. Therefore, we have a new state which is written as Q0, Q2. In this manner, we go ahead with all the other transitions. So when we are considering the next set, that is Q0 and Q2 state. So it will be Q0 and Q2 state. Union of this will be Q0, Q1 union 5. So Q0, Q1. Next we have Q0, Q1, Q0, Q2 on B. So that will be only Q0. Then it is Q1 and Q2. So Q1 and Q2, no transition defined, and Q1 and Q2 on B, a single transition, that is Q2. Next it is union of three states. So Q0, Q1 and Q2. That would be Q0, Q1, and here it is Q0, Q1 and Q2 on B. So Q0, Q2. I have not written these steps for all the transitions. I have directly written using the tabular format.
I'll do a simple renaming of states here. This will be delta D, A and B. Instead of these states, I'll call them as A, B, C, D, E, F, G and H. And we know that Q2 was our final state of NFSM. Therefore, wherever Q2 is present, it also becomes the final state. So we have got Q0 as the start state. So B is our start state. D is one final state. F is one final state. G is another final state, and H is another final state. Therefore, here it will be A and A. Then we've got E and B, A and D, A and A, E and F, E and B, then we've got A and D, and E and F. The next part which we have to see is which of the states are reachable from the start state. Therefore, if B is our start state, B reaches E and B goes to B. So we know that from the start state, E is reachable. And E reaches E, and from E you can reach F. And from F you can reach E and you can reach B. So B is already our start state, so we come back here. These are the only three. Therefore, from the start state B, we can only reach states E and F according to this transition list. Therefore, we can eliminate all other states. We need not have them in our transition diagram, state diagram. We can maintain only three states, that is B, E and F.
So we have Q0 as the start state, and Q2, wherever Q2 is present, all those states are considered as final states. And I had also done a simple renaming: A, B, C, D, E, F, G, H. And from this we came to know that only states B, E and F are reachable states. That is, E and F are reachable states from the start state Q0. Therefore, we eliminate all the others. We need not consider these states in the final state transition diagram. So the state transition diagram goes like this, of DFSM converted goes like this. We have our start state Q0. Q0 on seeing A goes to Q0 Q1 state. And on seeing a B, it remains in the same state. Now Q0 Q1 state. On seeing a A, it remains in the same state. On seeing a B, it goes to Q0 Q2 state. Q0 Q2 state on seeing a A goes to Q0 Q1 state. and on seeing a B, it goes to Q0 state. So we have one final state here in the new diagram. So Q0, Q2 is considered as the final state. Therefore, for the NDFSM, Q0, Q1, which was having AB as the ending substring, then the DFSM is written like this.